Hello, good morning, good afternoon, good evening. Thank you very much for joining this Kafka Master course. Of course, I'm not Kamesh. Kamesh cannot make it today, so just for today, me is going to be the instructor of this course and Sebi will be on the chat answering your questions, because remember that any question that you have, you can see on your right or in the bottom, there is a message box where you can just type your questions. Let me put first of all some links before. This is the homework, as usually in our master courses. There is all the things that we are going to show you, and more things are explained there. So this is just homework, so you can replay on your own at home after this session. And of course, we're going to share with you the slides. I mean that all the slides that we are using are just here. Okay, I pasted it on the message chat, so you can take it and try it at home. So let's start. Remember that today we've got this Kafka session. It's just a single Kafka session, so just for today on Monday. But on Wednesday we've got Knative session, right? So if you are interested in serverless ecosystem, serverless in Kubernetes, then Knative talk is for you, and at that time it will be done by Kamesh for sure. Then, my name is Alex Soto. I work in Red Hat. In fact, I'm working in the same team as Kamesh. If you want to be updated with all the new things about Java, Quarkus, Kubernetes, Istio, Knative, Kafka, you can follow me on Twitter. Also, if you've got any questions, anything, just follow me on Twitter. So, as usually, we've got our survey, right, where you can just give you your opinion, what would you like to improve, what's not. So I'm going to share with you this as well in the chat room, so you can just fill with your opinions. And we are almost done for now. Just saying that in this master course we're going to see what is Kafka, why you should use Kafka. Of course, you should use Kafka in some specific places, not in, it's not a silver bullet, right? So you still need probably a database, but Kafka can help you a lot. We're going to see topics, partitions, consumers and producers, Kafka Streams, windowing, and finally, of course, we're going to see how we can deploy Kafka in Kubernetes in a really easy way, thanks to Streamsy. So let's start with a really quick demo so you can just see what you can do, right? I've got here my cluster. Well, in fact, it's the Sebi cluster, right? But yeah, we can say that it's it's a cluster. I've got here an application, a Knative application. Basically, this Knative application, what it's doing is just exposing a service. In fact, I can do Kn service list. You can see that I'm exposing this service, and when I run request to this service, then this service is going to send some events to a Kafka broker, and then Knative is going to react to these new messages inside the Kafka broker and will start some pods to treat these messages and execute some kind of logic. Okay, I know that now it might sound a bit strange, but of course now with the course of today you're going to learn to do the part of Kafka, and then on Wednesday, if you join us, remember to join us on the webpage. You join, then you'll be able to know how to do the part of the Knative. So let's start with this. Notice that there is no pod. In fact there is one pod, but this pod is just, it's the glue, right, between Knative services and Kafka. Okay, and then if I'm going here, I can do kufctl exec, kufctl, wait, because it's in another namespace. Okay, here. So now I'm just getting inside a Kafka, a pod. I'm just inside a pod. Okay, and I'm going to do a call to this local service. This is just a service that sends a message to my Kafka broker. Okay, the important things here is that notice that there is no logic pods here. Then I can do a call localhost, localhost 8080/3. So what I'm saying is like, okay, now send 3 messages to the Kafka broker that I've configured inside Kubernetes. So run it and notice that what's happening here is that 3 pod has been started to execute the logic, right? Because what is happening here now is that this localhost/3 is sending messages to Kafka broker, and then Knative are listening this Kafka broker, and every time that he checks that there is a new Kafka message, it just starts a pod and executes some logic. So you can see that, of course, this logic, there is an auto-scale process. So I mean that you are not executing 1 pod per message, but the first time, since there were no messages, then Knative started some pods, so these messages can be treated. So as you can see, because what's happening now is that thanks Sevi, I didn't change the console. Oh man, yeah, this is something that it's going to be fixed sooner than later, because I've got here my Stream Deck to change, but now I've got another computer, and usually I remember to switch my screen, but yeah. Sorry for that, but well, we can execute it again, so it's not really complicated. Probably you already listen my my explanation of that. We've got Knative and we've got Kafka broker, and then this Kafka and then Knative is listening all the Kafka messages, and when we send a message to this Kafka broker, then Knative reacts, starts some pods, and executes some logic. Okay, and as I said, I am in the pod, and I'm just going to do call localhost 8080/3, and now what I'm doing here is just sending 3 messages to the Kafka broker, and notice that here now some pods are coming to life. These pods are coming to life because Knative is just checking for any new message in the Kafka broker, and when the Kafka broker is up and running, receives the message, Knative listens this message and just start these pods and execute some kind of logic. So now that you've seen that, let's start to see the Kafka part. I think that I've got, no, not yet, but that's fine. I'm going to the slides. Yeah. So, why Kafka? What is and why Kafka? Okay. Then, basically, Kafka is a publish-subscribe system, the same that we've seen before with JMS, for example. It's the same, but it's pretty much cooler, right? You see that it's more faced towards the microservice architecture. Notice that it contains all the fault tolerance logic by construction. It's not something that you need to think about it. It's just been built having fault tolerance in mind. You see that you've got a Kafka broker that you can replicate across clusters or several different clusters, and then we've got that we can have several producers and several consumers for fault tolerance and duplication. And one of the great things about Kafka is that you can start processing all this data in real time. So this is one of the big difference between the traditional relational databases, where if you want to do some kind of processing, you should do it with a batch processing, right? Now with Kafka, you can do all the things in real time. We are going to see it in a few moments. So what is that really big difference between relational database and Kafka? Okay, the difference is that, first of all, in case of a database, you've got entities, right? The main concept is an entity. For example, it's my plane. Meanwhile, in the Kafka or in the messaging systems, the main, if you wish, concept is an event. right? Here is an entity and here is an event. The second difference is that when you're in a database, you can insert, for example, a plane, but then when you update the plane, you are updating the entity. So you're overriding the previous value with a new value, right? So it's an overriding. You never have a full history by default of what's happening to this entity, right? But in case of Kafka or a messaging system, you are storing messages. So you can store my plane, but then if you update the plane, this update is another event. The original event is not overridden. So you've got a full history of all the things that happened to my plane. Of course, as I said, with Kafka, you've got the real-time processing. Meanwhile, with database, you need to go towards a batch processing to know exactly what's, to get some important business data from the database. In case of Kafka, you can have it in real time. And the next thing is that in case of Kafka, there is a distributed fault tolerance in mind. Meanwhile, in databases, well, they were not built in that way, right? You can do it, of course, but you'll see that it's really easy with Kafka, and with databases, sometimes it's a bit more difficult. It's true that the new generation of databases are having all these kind of things in mind. For example, I'm thinking in CockroachDB, where the fault tolerance and replication is implemented by default. But let's say that in traditional databases, this is not the case. Of course, you don't need to use Kafka all the time. Sometimes in some problems you might need a database, and that's fine, and sometimes you might need Kafka. For example, as I said, when you want to start getting results in real time. So, what are the basics of a Kafka broker? Topics and partitions. So, we can say that here you see that there is a Kafka broker, okay, and then we've got topic A, topic B, and topic C. You can think like topic, it's like, the topic is the place where you queue things, right? Where you send messages. You can have several topics inside the Kafka broker. And several producers can send messages to a topic. Of course, in this case, I've got two producers sending messages to topic A, and I've got another producer that is sending a message to topic B. And of course, you might say, then what's happened with topic C? Well, maybe it could be another producer, or it could be another topic that sends messages to another topic, okay? And then we've got the consumers. The consumers are the one who are, as the name says, consumes all the messages, right? And we can have, for example, one consumer consuming from topic A and two consumers consuming from topic B, okay? Notice that there is some kind of redundancy, that sometimes it's okay, right? Because you might want to have high throughput of your data. So you need more than one consumer to be able to process all the messages that are reaching the topic. In this case, for example, topic B. But of course, if we go deep into the topic is divided by partitions. So when we say that the producer sends a message to a topic, that's not entirely true. As well as we cannot say that the consumer is the one is getting messages from a topic. The messages are produced inside the partition and are consumed in a partition. And the reason that they're having several partitions is for improving performance, because each of these partitions can go through different machines, right? So we've got a topic A where we want to send messages, and then since we've got several partitions, we can split out this data and have all this data in several machines. So in this way, we are improving the performance of the broker. And of course, we can have the Kafka broker replicated. So we can have one Kafka broker with topic A and 3 partitions, and then we can have another broker with the same topic and the same number of partitions. But notice that in this case, this is a redundancy. So if this Kafka broker or this partition, the machine of this partition goes down, then we've got the data automatically replicated. So if this machine of partition 2 is down, then the data will be grabbed from this other partition too. So you can, replicate the Kafka broker, replicate the topics, and replicate the partitions, just for redundancy, and in the latest versions for performance as well. We said a lot of things about consumers and producers, right? We said that consumers are the one who consumes the messages from the broker, and producers are the ones who are producing messages into the broker. But let's go deep inside them. So this is a topic A, partition 1. As I said, a topic, it's composed by partitions, one or several partitions. In this one, this is the partition 1. And we can see that we are sending events or messages inside this topic. This is the time 0, this is the time n. So always the time is linear. Then an event it's composed by a message, and a message contains a key value, a key, and a value, right? The key is not mandatory. If there is no key, then Kafka broker assigns 1 by default for you, okay? I mean, that's totally fine to do not expose a key to a message, but I recommend you that always your messages have a key and a value. Then, what you see here is that we've got several producers. As I said, that some people can send, more than one producer to a same topic, but the producer always produces messages at the top of the topic. So at the end of the topic, if you wish, right? So always the producer just send a new message, it's appended to the topic. But the consumer can consume messages from any point. So you can say, okay, a consumer, just consume all the new messages. So you're going from the top of the topic, or you could say, consumer, start consume elements from this position. So it could be, a position from the middle of the topic or from the beginning of the topic. So in case of consumer, you've got the concept of offset. So you can choose at which point you want that the consumers start processing data. We're going to see it in a few moments in a demo. And if you ask me, a producer, how he knows where to store the message, because remember that we said that the Kafka broker is composed by topics, and topics contain several partitions. So how you choose where messages are stored? It's in a function that notice that this function is outside of the Kafka broker. It's in the producer side. If you do not implement anything, then it just do the hash of the key, and depending of this hash, it sends the message to partition 1, 2, or 3. And notice that for the same key, the value is going to be all the time in the same partition. But of course, you can override this function, and you could say, for example, things like, if the key is, for example, a client, and I know that my client is in India, for example, then I'm going to put this partition to the India data center. And since this function detects that the key is for an Indian client, then I can choose partition 1. If it's, for example, another one, which is, for example, for Japan, then I said, okay, partition 2 is going to be for the Japan clients. And then this function that is in the producer is going to send the messages for Japan to the partition 2, right? So this is one of the great things of Kafka, that the function to decide where to store the message, in which partition, it's on the producer side and not in the broker itself. And there is another thing, right? We have always been talking about consumer, we've got consumer and that consumes data from a partition, but the truth is that we can have more than one consumer for one partition, and this is what it's called consumer group, right? Then what's happening, for example, we've got 3 partitions and we've got a consumer group 2 with 1 consumer. Then what this means is that this consumer is getting messages from the 3 partitions, okay? But what's happened if I've got another consumer group with 2 consumers? In this case, partition 1 and partition 2 might be processed by this consumer, and partition 3 might be processed by this other consumer. Notice that in this way we can scale up the processing power, right? Because the more consumers we have, more processing we can do in parallel. Of course, there is a limit. The limit is in the number of partitions. So in this case, at top, we only can have 3 consumers. Because if we've got 3 consumers, the consumer 1 will be with partition 1, the consumer 2 will be with partition 2, and the consumer 3 will go to partition 3. Okay, so this is the top. If we've got 4 consumers, then there will be 1 consumer that is in a stale. The good thing about this model is that if this consumer goes down, then there will be a rebalance, and this consumer will take the 3 partition at once, right? So as you can see, Kafka have the fault tolerance in mind all the time. So let's start with the demo so you can all see all these kind of things in motion. Okay, in a demo. I'm just starting Kafka in my local machine. In fact, I'm using Docker. And now, for example, one of the things that we can do, well, we can do a Docker PS so you can see that, you know, there is Kafka started. Notice that now for version 2.4 and 2.5 and so on, there is 2 pieces of that you need. The first one is the Kafka itself, and the second one is Zookeeper. Zookeeper is going to be removed in the future. Okay, now that there is some, and with Kafka 2.5 there is an experimental mode to run without Zookeeper. But for now, you need the Kafka server and the Zookeeper. Okay, I've got this running locally. Then, see if I do, for example, Kafka Cat. Okay, Kafka Cat is a tool that you can download, and it's really cool for start checking what's going inside our Kafka cluster. I can do a Kafka cat-l. Whoops, I've done something wrong, which is wait -b. And now, and notice that it says that I've got a broker 0 at this port and this host, and yeah, there is only 1 broker and 0 topics. Of course, if I had several brokers with several topics and partitions, then I could see all the information here. But now, let's do another thing, which is, for example, creating a topic. By default, when you try to produce something to a topic, if the topic is not created, then some defaults are used to create this topic. So you do not need to take care of it. But of course, probably what you want is to create the topic using a specific parameters. Then, when you install Kafka, it comes with 2 shell scripts to do that things. In this case, since I'm using Docker, I can just go inside this container, which is this one. Now I'm inside the Kafka server. I'm inside the machine of Kafka. Notice that this is all the Kafka things, and notice that there are a lot of shell scripts, and these shell scripts are shell scripts to manipulate the server. In this case, I'm going to do a /bin/Kafka Kafka /topics.sh, and I'm going to copy here so you don't see me typing all the time. What's happening? Wait. Okay, I'm going to do another thing, which is copying everything. And now, okay, now notice I'm just creating the Kafka topic. I want to create it using the local host with 1 replication factor. So I'm just saying that I don't want to replicate this topic to other Kafka brokers, and I don't only want 1 partition because I've got only a single machine, so it will have not much sense to have several partitions. But of course, if you start in Kubernetes, which we're going to see by the end of the session, you will see that you can create several partitions as shown. In this case, I'm just creating 1 partition, and the topic is going to be called songs. So I can execute it. And now, if you want to see here in the using the Kafka topics sh, I can do --list, and you can, it will print me all the topics, which in this case there is only one, that is called songs. Now I'm going outside of Docker container, I can do the Kafka cat -L and see now that it says that there is one broker with one topic. The topic is called songs with just one partition, the partition 0, the leader of the partitions are 0, there is no replicas, and that, and done. Okay? Notice that if we will have several replicas with several partitions, then there will be for each partition one leader. Okay? But now, since everything is 1, 1, 1, 1, everything is with no leader. Then let's insert some data, some messages inside this topic. The first thing is that one tool that I really love is Kafka Cat. Kafka Cat, it's a tool that you can download it and helps you to inspect what's going on inside the Kafka. It allows you to see what's happening with this topic, with this other topic. I can insert data to the topic and so on. So let's do, for example, Kia Kafka Cat -b localhost, localhost, the host. Okay, and now what I want to see is just print all the content from the songs topic. -t is to say the topic, and then we've got the -c because you want to consume. Okay, it's in fact, in this case, it's creating a consumer to the songs topic. Notice that it says that there is nothing, right? Offset 0 because there is no elements, no messages of topic songs. But now, let me show you. This is found in documentation, modules, root, examples, initial songs. I've got this JSON or semi-JSON where this is the key and this is the value. Okay, so I'm just creating a key value. This is key 1. With key 1, I've got this JSON song. Well, this description of the song, which is the ecstasy of gold of Ennio Morricone, and I'm just creating an operation which is add this song, and I've got for the key 2 this other song which is Still Loving You from Scorpions. Okay, now I can do Kafka Cat -b localhost 29.92 -t songs. And for example, here this is the songs. This is the file that I want to add. And notice that now here Kafka Cat has reacted. Notice that it's in real time. I'm just not doing like in a database that I should do some kind of daemon, or for example doing a batch process executed every minute to check what has been added. Notice that I'm just added this information and automatically all the information has been put it here. Of course, for example, one other thing that I can do now is just, for example, stop this Kafka Cat. So I'm stopping the consumer and I start the consumer again, and notice that again all the data is still here. The reason is that by default Kafka Cat and all the consumers are getting all the information from the beginning of the topic. So it's just getting all the messages from the topic and just print it there. But what's happening if I do another thing, which is I manipulate the topic. So sorry, the offset. So instead of saying I want to get all the messages, I said that I want the consumer start consuming messages not from the beginning but from an offset, and the offset is 1. This offset 1 means that I want to skip the first message. Now if I run it, notice that I've only printed the first, I have skipped the first message, I only printed the second message. Okay, so you can see that with this concept in Kafka consumers, where you can start consuming from any point of the topic. Let me see if there is any question. We'll see that there is some questions. Let me move it here because it's not, I cannot see it. There are different. How to acknowledge words between producer and consumer? No, you cannot acknowledge from producer and consumer. You can acknowledge that the producer has produced it correctly and all the messages has been stored correctly, okay? But yes, I think that exactly, this is what Sebastian says, yeah. Yeah, it's exactly what Sebastian is saying. Yeah, I was mentioning that when the consumer commit, it does against broker, not producer. No. Exactly. Yeah, the consumer it's in one place, producer is in one place, and they are decoupled somehow, right? So it's the topic who is the topic of the Kafka broker who is in charge of communicating between both pieces, but there is no direct communication between producer and consumer. It can be Java, but there are clients for any other for any other language. You said, is about Kafka consumer is one Java instance and have multiple consumers or only one consumer? Yeah, if you want to have, I mean that you can have one Java instance and then multiple consumers if you want, or if you want, you can have several Java instances having multiple consumers. So this depends on how you want to scale up. This is one of the great things about Kafka, that you are not tied to any kind of model. You can have one Java program with multiple threads, these multiple threads having the several consumers, so you're getting the parallelism at JVM mode, right? Or you can have several different instances of Java having several consumers. So both models are perfectly fine, and it will depend on your use case that to use one or another. Okay, let's continue with the demo. Another thing that we have in Kafka is the retention. So the messages by default are kept there for 1 week. So during 1 week, the topic will contain all the time the same messages, okay? And after this week, then by default, Kafka will remove these messages. You can change this, and you can make it them persistent forever, if you will. And Kafka will work perfectly, okay? But usually, since what you're interested when using Kafka is streaming in real time, getting some results, and then you don't care about the streaming things that happened 1 week ago, usually you add some kind of retention, you modify the retention, right? And in this case, I'm going to change the retention. Notice that if I'm here and I'll do again Kafka cat, so I created a consumer from the beginning, it's still with the 2 messages. But now, let me do the next thing. Let me go inside the Kafka server again, and let me configure the songs topic with a retention of 10 seconds. Notice that I'm just running Kafka configs. Again, this is a shell script that is provided by the Kafka installation. So if you install Kafka locally on your machine, then you've got these scripts there. Since I'm using Docker, then I need to go inside the Docker container, and I'm just saying that I want to alter the topic songs, and I want to add a retention in milliseconds of 10,000 milliseconds, which is 10 seconds, okay? Now it says that, okay, I've completed this, and even if for example, I can do a describe. This is another tool that you're going to use a lot, which is this Kafka topics describe. Notice that it says that the topic songs has one partition count, one replication, because it's alone. And if you see here, there is a retention in 10 seconds. So as I said, I've configured this retention to 10 seconds. Now let me go out and let me, for example, add again, okay, some songs, which is here. Okay, now I'm adding songs. Let me, for example, do this again. Okay, we've got 2. Now I've added the same songs again. Notice that it's printed and the offset is 4. Okay, and now what's happening if I close this and we wait for 10 seconds, because I want to show you how the retention works. Let's wait for 10 seconds. And now, what's happening if I said, okay, show me all the contents from the beginning. Wait. Sometimes what's happening, sometimes it works in this way because it takes time to populate this information. No worries. What I can do now, before that, is I can delete. Let me show you how to delete the topic and do exactly the same again. Because sometimes, as I said, happens these kind of things that when you are in the local machine, it takes some time to delete. Let me delete this topic and recreate it again. It's not a problem. Notice that now I'm saying Kafka topics minus delete bootstrap blah blah blah, and notice that here now the offset is 0 again. The reason that is offset 0 is because I've deleted the topic. Then let me create again the topic as we've done before, and let me change the retention. Whoops, topic already exists. Okay, that's fine. Okay, now I've changed the retention again. Now let me insert all the data. Notice that I've got here again the 2 songs. Let's wait for let's put 15 seconds, just to have some kind of buffer between all the retention is updated and so on. And now it's done. And now probably when I do this, wait, the retention is not working. Why it's not deleted? It's just a mysterious to me now, because it should, maybe I'm doing something wrong. In theory, not. Now, because as I said, usually it takes more time. Notice that now it says that there is no data. I can do a clear. Notice that it says there is no data, but the offset is 2. The reason is that one thing is deleting messages, another thing is deleting offsets. It's 2 different things. The offset is a counter. It's incremented and it's reset every week as well. But the content, the messages now are gone, and are gone because of this retention time, right? So you can insert things, create a retention times, and then after this time, the messages are removed from the topic. Yeah, as you can see, it works. Now, let me go back and configure, I can delete it again. So I can delete it. So the next time that I created the topic, it will be created with the default timeout again of 1 week. Okay, now you've seen the basics. You've seen that what is a topic, what is a partition, that can be several partitions, that you can have several consumers, you can have several producers, and yeah, and you've checked the Kafka Cat tool for all the time knowing exactly what's going on inside the topic. You can stream the contents from the topic, produce elements. You've seen the retention, right? That Kafka can remove automatically messages in a specific retention time, and you've seen the offset that the consumer can start consuming all the data from any point. Okay, then. Of course, this is using Kafka Cat, but if you want to see how to use it, for example, in Java, we can say, I can show you, you'll see this example, right, in the links that I've sent you, but you'll see here that, for example, the song APP is in a Spring Boot or a Quarkus. I mean, that is implemented in a Spring Boot and Quarkus. I'm going to show you in a Spring Boot. If you check here, if you want to see how you can start getting information from a Kafka topic, you only need to create this auto-wired Kafka template. This is the typical thing that Spring Boot works. You create this Kafka template, and then you just create from this Kafka template. If I want to send a message, then I've got Kafka template.send. I pass the Kafka topic, the key, and the value, and then this method sends something to a Kafka topic. Okay, this is how you can do it this with the Spring Boot. If you want to say, for example, how to do the same in Quarkus, then it's more or less, you will see that it's more or less the same. But in this case, you've got one class which is called emitter, okay, which it's songs, and I have to create a Kafka record of the key and the value, and then I do songs, which is this emitter.send, I send the message, and done. Okay, this is how you could do it with Quarkus. This is for sending a message. How you can get or create a producer? Well, in this case, in case of a Spring Boot, I've got here the code. You see that I simply have a Kafka listener. So I annotate my method as a Kafka listener of this topic, and then I'm saying that the payload is this string is the JSON, then I'm just parsing this JSON and printing it, right? Nothing really new or interesting, it's just, you know, using these annotations, and then for every message that is sent to this topic, then this method is executed. In case of Quarkus, you can go here. It's pretty much, you will see it's pretty much the same, because at the end it's similar technologies, right? And I'm just creating here Kafka, a flowable of Kafka record of the channel songs. This is the topic, okay? The topic, I'm saying that I want to get all the messages from the topic songs, and then I'm just creating this thing, right? This is how you can get events from the Kafka topic in Spring Boot and in Quarkus. Of course, if you're interested in Quarkus thing, we've got the master course in 3 weeks or 2 weeks where you're going to see how to implement it. But just, you know, you see that we've seen in using Kafka Cat, but you can also use Java for doing this. Then next topic is Kafka Streams. What is Kafka Streams? Well, we've seen that we've got topics. We've got topic A, topic B, but sometimes you want to create some kind of operations between topics. So maybe you want to do a join between two topics, or maybe you want to start processing these topics in real time, but doing some kind of aggregations between topics or counting elements inside the topic and so on. And this is exactly what is Kafka Streams. Again, Kafka Stream is a Java application, okay, that runs outside the Kafka broker. So notice that the Kafka Stream is working from outside Kafka broker, which means that we can parallelize as much as we want, right? The great thing about these Kafka Streams is that at the end it's just a consumer that gets all the data from the Kafka broker, and then we can apply some transformations, some operations, okay? We can aggregate elements, we can join between topics, we can create tables, Kafka tables, that we're going to see it in a few moments exactly. And of course, we can even create interactive queries. So for example, we can process all our data in real time and then store it locally so we can get it from another application. As I said, Kafka Streams is a Java application. It's deployed as a JVM application process, so you can have as much as you want, so you can parallelize all the workloads. It's elastic and highly scalable because at the end, you know, it's separated from your brokers. You can just start JVM processes or start pods, and then they will start processing all of them. You can deploy to containers, virtual machines, bare metals, clouds, whatever. It's integrated with Kafka security model, and it supports exactly one semantic, which means that you can avoid processing duplicated. Okay. Now, usually, when you want to start using Kafka Streams, you want to start doing joins between topics, okay? But one of the things that you want to do is process them in real time, but into a scope time, right? Which is called windowing. Windowing is the way that has Kafka to get some kind of, scope or for when the data is valid. And there are different ways of doing this. One is tumbling time window. What you're doing here in this specific example is that I want to create a window of 15 minutes. So it means that all this data of this topic is processed together every 15 minutes. So all this process is processed together. So for example, if you're counting the number, if you have a process which is counting from topic A, the number of elements yellow, you will receive here 2, here 2, here 2, and here 2, right? But you're not going to receive at any time 8. Always it's 2, because you are creating some kind of windows of 15 minutes. So the data is processed in intervals of 15 minutes. And in this tumbling time window, it's a static time window. It's like every 15 minutes, it's reset and the processing is started again. Another one is hopping time window. It's exactly the same, but now you are just setting, I want a time window of 15 minutes, but I want to start a new window every 5 minutes. So what's happening here is that one window is valid for 15 minutes. Notice that every 15 minutes is started one, but also a new window is started every 5 minutes, right? So notice that in the first case, you're receiving all these elements, but in this case, notice that you're shift by 5 minutes. So it means that here you're moving you're shifting the window as well. So you're not receiving the first event. And then after 5 minutes, there will be another window with, again, with the shifted. And in this case, you are not receiving the first element, but you're receiving one element from this window, right? Because there is a shift of the windows every time. So it's like 15 minutes, and every 5 minutes you start a new window, and that's important. And the third one is session time window. And session time window is used for analyzing the user behavior, okay? And that's quite complicated. The thing is that you create a window per key. That's the big difference. Notice that here you are creating a windows for all the data that is happening, right? And here you are creating a window per key. And this key, for example, could be the user ID. For example, I'm Netflix and I want to analyze the behavior of a user X. Then I create a session time window for this user X. The big difference, notice that here you've got a big window and here you've got two windows. The reason is that the session time window, you also define some time of no interaction, right? So if you say, I want to create a session time window that if there is no interaction in 15 minutes, in this case, of course, this is configurable, then stop the window. So now the end of the window is not fixed by time, but it's fixed by the user behavior, that by the user interaction with your system. In this case, you can see that the user yellow, this one user, has done a lot of interactions, so there is no gap of 15 minutes of inactivity. So the window is always open. But notice now the red one. The red one is creating a window. It creates two events, so two messages. For example, it could be I start the movie A and now I start the movie B. But then in 15 minutes, there is no interaction of the user red. So the windows is stop. Then after some minutes, there is another interaction and it creates a new window. As I said, in this session time window, the windows are not stopped by a fixed time, but by the user interaction. And now, since there are interactions all the time, without getting a 15 minutes gap, then the window is always open. I know that it sounds quite complicated, but this is how it is, and it's really useful when you want to start analyze the user behavior. As I said, the example of the Netflix is really cool, right? Because you can exactly know the behavior of a user of, playing all the movies or series, and you can just start doing some analysis of which are the series that are seen most of the time without an interruption. Because if you see this user, and we can think like this yellow is a user doing a play of a movie, you see that he's not really happy with the movies because he's changing quite often from watching one movie to watch another movie, right? In this case, this user seems more happy because it's a state 15 minutes watching what he chooses to see. Of course, there is one thing that is called retention, that sometimes some events can come out of time. For example, we can have an event that is happening at 23:05, but it arrived at 23:30. This can happen because of delay or whatever. Then this you can configure the retention of these session windows so this event is processed correctly. So let's see examples of this windowing thing and global tables. Well, we can just go to show this, and for example, we can create. Let me show you this. I've got another tool which is called Streams cat. It's a Java tool that allows us to play with Kafka Streams. Now this tool is going to create a Kafka stream of a time window of 20 seconds. Okay, so it's going to create that every 60 seconds I want to count the number of messages that has been added to the topic songs. And I'm going to, as you can imagine, I'm going to create the first songs. And now I'm going to print them. Notice that I'm saying, if you check, let me do a cat so you can see what I'm doing here. Notice that I'm creating 4 elements for Alex, 3 for Bor, 2 for Kamesh, 1 for Edson, and 1 for Sebi. And notice that I'm just aggregating all these elements. So Alex, there are 4, Bor, there are 3, Kamesh are 2, Edson are 1, and Sebi are 1. Now, what's happening if I added them again? Since I am outside of the time window of 20, right, because probably it has elapsed more than 20 seconds. Sorry, I've done incorrectly. Now, notice that I'm resetting again and saying that Alex is 4, Bor 3, 2, 1, and 1. But if I've done this inside the same time window, let me do it in the same time window. Now, notice that now I've got Alex 8, Bor 6, Kamesh 4, Edson 2, and Sebi 2. The reason of this is that the first time every 20 seconds a new window is created. In this case, if I created messages inside the same time window of 20 seconds, then the messages are counted in the same session. If not, then it's reset and it's like a new counting. Notice that now I'm counting again with 4, 3, 2, 1, 1. Now, let me show you another one, which is with a session window. With a session window, I can just run this. Again, this is something that I can do with Streams cat. Streams cat again is a tool for manipulating or playing with Kafka Streams without having to code anything. In this case, I'm creating a session window of 60. Creating a session window of 60 means that the window is reset when there is no interaction in 60 seconds. So if there is 60 seconds without any new message for a given user, then the session window is closed. So let me run the first batch of users. Okay, and let's see. Okay, now you'll see something 4, 3, 2, 1, 1. That's fine. And now I'm going to run here in a script because it's easier to do it with the script. You'll see everything. Now I'm adding more elements, right? So you can see that this has been updated, and it happens that before it was 4, now it's 5, 8, 6, 4, 2, 2. And now I'm asleep in 30 seconds. So notice that 30 seconds without sending any new message means that when I send more messages, the session window is exactly the same because it has not been 60 seconds without interaction. Okay, and notice again that all the things occurs at streaming time, in real time. Notice that now after 30 seconds I've inserted again elements and now I've got 12, 9, 6, 3, 3. The reason is that I am still in the same session window because that there has been an interaction between before this 60 seconds. Now I'm waiting 40 seconds. What's going to happen after 40 seconds is that I am still in the same window. I know that if you check here, it has passed 70 seconds from the beginning. But since it has been an interaction, then this time is reset. Okay? So what I mean is that it needs to be 60 seconds with real no interaction. If there is any interaction between these 60 seconds, then the time is reset and you need to wait 60 more seconds to check if the window is closed or not. And notice that here, if you see here the result, you see that it's 16, 12, 8, 4, and 4. But now I'm waiting 65 seconds. So there is 65 seconds with no interactions. So what's going to happen now is that the session window is going to be closed because I've configured that the session window is for 60 seconds without interaction. There is no interaction, so the session window is reset, and a new session is created when new data is inserted. And this is something that we're going to see right now. Okay, let's see. It happens this 60 seconds. This is the session window. This is the 60 seconds are the time that we are waiting with no interactions. If there is one interaction between this, then there is no reset. I mean that there is a reset and you need to wait 60 more seconds. Notice that now I've waited for 65 seconds and now, notice that now Alex was 16 and now Alex is 4. The reason is that this elapsed time has passed, there were no interaction, so I created a new session window. So as you can see, with session windows, you can analyze the user behavior really, really easily. Now we are almost out of time, but not out of time yet. So I can show you another cool thing, and is how to deploy Kubernetes, Kafka in Kubernetes. And I'm going to use a Streamsy project. So for example, I can do kafka get CRDs, and notice that Streamsy at the end is just a CRD. Notice that I've got here Streams installed, and with a custom resource definition, I can do things really, really cool. And let me show you how easy it is to deploy a new Kafka broker with 3 partitions in a Kubernetes cluster. I'm going to just use this CRD. Notice that since I've installed Streamsy in my Kafka cluster, and of course this depends on your cluster. With Minikube, you do it in one way. In OpenShift, it's really easy to do it. And for example, in this case, I'm just creating a new YAML file of time Kafka. I want to use the Kafka version 2.5.0. I want 3 replicas. I want to be configured in this way. Okay. I want a storage ephemeral, and the zookeeper also I want 3 replicas. So now the only thing that I need to do is just run this. I can run it in this way. So I'm running this file. Notice that says the Kafka has been created, and now I can kubectl get pod. Oops, not yet. Kubefns default. Kubectl get pod. Okay, what's happening now? Kafka plus Streamsy, my cluster created. Kubectl get Kafka. Okay, now here you can see that my cluster has desired 3 Kafka replicas and desired 3 zookeeper replicas, as I said. Now, I don't know why probably it's deploying, but it's deployed somewhere, but I don't know where. Kafka get Kafka -m default, yeah, get pods, get services. Now the cluster is created, but I cannot find context. Modified, space. The only thing that comes to my mind is that let me run it again. Change it, yeah, of course. Kafka get pod. Carol describe Kafka. Notice that it says that the version is unsupported. Okay, now this is happening because the well, it's really easy. What I need to do: delete Kafka minus delete -f. That's really, I mean, what's happening here is that I'm trying to install a Kafka version that is not supported in my current cluster. I'm going to delete, and then the only thing that I need to do, which is really easy, is just copy this and just change it. I can go here, bi Kafka, .yaml, and I just need to change this to .4. But notice that how easy it is to deploy something. I mean that I just need to change this resource. This is in Kafka Kafka, and now if I do get Kafka get pods, you can see how the Kubernetes cluster is being created automatically with just this, just configuring the Streams in my Kubernetes cluster, and then just configure that I want 3 replicas, and notice that the 3 replicas are going to come to life. I mean that now it takes a bit of time because it needs to download the images and so on, but when the images are downloaded, it's fairly fast to run it. Let me see if there is any question. Meanwhile, there is no questions. Yeah, I think that the windowing, the difference is more or less clear with the example. And I think that it's pretty much all. You've seen that the important things of Kafka, right? That you can replicate it, that it's fault tolerance by default, so you can create as much as consumers and produce it as you want. You've got the partitions. The partitions can be replicated. Partitions are there because we want to have resiliency and also improve the performance. We've seen that the consumers can get it from any messages with an offset, so it can be from the beginning, from the end, or from the middle. Then we've got producers that always produce at the end of the messages. We've seen Kafka Streams, right? If you want to see an example of Kafka Streams in Java, you can just go here to our Kafka tutorial, and if you check, for example, in this case, music chart, you can see here that I'm just doing a chart of the most played songs, and it's just Java code where you are saying that I want to join all the songs with the played songs and then aggregate the numbers. So with aggregate, you are aggregating, you're summing the numbers. Okay, and that's all. And notice how all my Kafka cluster is now up and running. If there is no questions, then we think that we can conclude. Thank you very much.